Welcome to the video lecturing covering reflection. The learning target is for you to understand how a figure reflects in a coordinate plane. The two success criteria for you is being able to reflect an image over a line of reflection, as well as recalling and understanding the coordinate rules for reflection. So we start with our core concept. A reflection is a transformation that uses a line like a mirror to reflect a figure. That line that it reflects is called the line of reflection. The distance between the point and the line of reflection is equal distance to the new image, which is shown right here. So the distance between P and the line is the same distance from P prime, which is the new image, to the line of reflection. That is the uniqueness of the reflection. If the image is right on the line of reflection and it reflects, it stays on that line. The vocab and core concept checked. Out of these four images, which one does not belong? Using the core concept previously, please try to answer this question. Pause the video if you like to give this a try. Here's the solution. The second one is having a triangle because it has a translation that slides it. The rest are reflections. Let me show you. This reflects it right here. Here's the line of reflection. Here, the line of reflection is right here. I try to draw it the best as I can. And likewise, this one also has a line of reflection. If this one had a line of reflection, the triangle would look something like this. If it was reflected properly, but it doesn't. So that is why the second one does not belong. It's the only one that didn't reflect. Example 1a. Let's see how it reflects over a vertical line. You're going to graph the original triangle, which is in blue, A, B, and C, and it has these vertex. A is at 1/3, 1, 3, comma 3. B is 5, comma 2, and C is 2, comma 1. And these are going to be reflected over this line, which is R. This is considered a vertical line because it is going up and down. So it's written in this equation, x equals to 3 in this case. Here's the solution. Notice point A is to how many distance to the line of reflection? It says 2. So therefore this also has to be 2. B was right here and it had a distance of 2 here, so B prime is going to have a distance of 2. Likewise, C had a distance of 1, so C prime is also going to have a distance of 1. That is how they construct the image after the reflection. Let's see how it works like here when it is reflected over a horizontal line. This is considered a horizontal line because it goes from left to right. The horizontal line here is defined by y equals to 1. Here's the point of A, which is 1, comma 3, B, 5, comma 2, and C, which is exactly on the line at 2, comma 1. Let's see the solution. Notice that A is 2 units above the line of reflection, so A prime is also going to be 2 units to the distance of the line of reflection. B was 1 unit to the line of reflection, so B prime is also going to be 1 unit to the line of reflection. C is on the line of reflection, so during the reflection it stays on the line like the core concept. So now here you can practice it by determining whether it reflects over the x-axis, the y-axis, or neither. Please pause the video and give this a try. So let's go over the solution. The first one, it reflected over the x-axis, and the green line of reflection is displayed to give you a visual. Number 4, it is neither. It does not reflect. It is actually a translation. It actually slide. 5. This one is neither as well. This one is actually a reflection, but it does not reflect over the x-axis or the y-axis. This one is a special case where it reflects over it reflects over the y equals to negative x line here. You're going to see number 5 later on. Okay, and number 6, does it reflect over the x or the y axis, or neither? We would say it is reflecting over the x axis. And what I drawn here is the line of reflection to show you that it reflects over the x-axis. Here's the core concept. There are certain rules from here that we could determine, right? It reflects over the x-axis. Notice that if the original is negative 2 over 1, right, the y-coordinate becomes a negative. You could see it down here. So that is the rule here. It reflects over the x-axis, the new point. There is a negative now. You change the sign on your y-coordinate, the b one. If it reflects over the y-axis, here you see that originally it was 1, right here, 1, and the new one was negative 1. They flip the x coordinate or the a value here, but nothing happens to the b. Sometimes you might have the y equals to x one, and this is one is when it flips. So the a spot, the negative 2 becomes the y spot, and the 0 becomes the, which is in the y spot, goes to the x spot. So here, this is when it flips spots. So do you see how it is AB? It flips. Okay, this one is the flip. This makes sense because this says y becomes x and x becomes y. So that's why this flips. Here, the last one, it flips, but it also changes the sign. Okay, and sometimes you might get a reflection over a particular line. Here, these are just through the axes. This is unique because it goes through a line in of itself. Example 2 is 2. Now we're going to see how it works when we reflect it over y equals to x. Here you see the original f, and the original point here is negative 1 comma 2. And when it got reflected, here's the solution. We follow the rule. If a comma b is reflected over the line y equals to x, which is what it says, the image flips. So it's now b comma a. So this was the original one. So the new one is flip. So the y was 2, it became the x, and the x becomes the y, so it becomes negative 1. And that makes sense because f prime here is 2 comma negative 1. Let's do it for g. Let's see if it makes sense here. G was originally, the x was originally 1, and the y was original 2. So look at g prime now. Do you see how the new x was the original y? And the new y was the original x. Do you see how it flips? Now I would like you to practice by graphing this polygon and its image after reflection. And here it is the y equals to x, so be very careful. Here's the solution. Here are the original points. A was 6 comma 3, B was 1 comma negative 2, and C was 4 comma 1. We apply that rule that we got from the core concept. If A and B is reflected over the line y equals to x, then its image is B comma A. It's flipped. So let's see if that makes sense. So we flip this. It becomes negative 3 comma 6. That's perfect. And 1 comma negative 2 is going to be flipped. Should be negative 2 comma 1. 4 comma 1 flips. Becomes 1 comma 4. Let's see if it makes sense. This is the equation for y equals to x. And this is the new point. Let's see if that made sense. They say A was up here, which is A prime at negative 3 comma 6. B prime is negative 2 comma 1. That is correct. And C prime is at 1 right here, comma 4. 1, 2, 3, 4. Perfect. That's how we know we did it correctly. Now, we're going to see how it looks like if we reflect it over y equals to negative x. Here's the solution. We flip this as well. So we flip, but we also change the sign. All right. So f was originally -1 comma 2. So now it's going to be flipped. So it became 2 comma 1. But do you see here it was a negative? But when it flipped, it became a positive. Okay, because this is what happens when it has the negative here. So this says it flips and changes sign. That's what I said earlier. Let's see if it makes sense here for G. G originally was 1 comma 2. So G prime would flip it 2 comma 1, and we change the sign. They were all positive, so now they're all negatives. And that is valid here. Okay. Let's try it here. Try your best. Let me help you out. The A value here is 1 comma 2. The B value here is 4 comma 2. And the C value coordinate is 3 comma -2. Now we're going to apply the rule. If A comma B is reflected over y equals to -x, then you flip it and you change the sign. So we flip it, it becomes 2 comma 1, and both of them are now negative. Right? This flips, it should be 2 comma 4, and there should be both negatives. That's correct. It flips, so in front it's now a positive 2 comma 3, -3, because it was a positive 3, now it becomes a -3. Here's the graph. This is y equals -x, and let's label these points. -2 comma 1 should be A prime. -2 comma -4 should be B prime, and 2 is right here, comma -3, 1 2 3 should be C prime. Let's see if we got that correct. We did get it correct. All right, so there you go. Those are all the potential ways for us to reflect an image.